Hi everyone. In the previous class, we have seen the concept of how to perform addition over BCD numbers, and also we have seen XS3 addition. Okay, right? Means when you are trying to perform BCD addition, when you are going to get an invalid number means whose range is from uh, not from 0 to 9, then I can say that it is invalid. So when you get like that, you have to make adding of plus 6 so that it will automatically comes into this particular range. Okay. Similarly, when you are trying to perform XS3 addition, if any carry generated, you are going to add plus 3. If there is no carry generated, you are going to subtract minus 3, right? So this is what we have seen, right? So if you observe these examples, right? 7 and 4 BCD addition and 7 and 4 XS3 addition, like that, right? If you want, I will take simple example. For example, let me take addition of 8 and 4. Addition of 8 and 4. In assume that it is BCD addition. BCD addition, right? So what is the BCD of 8? 8 is 1 0 0 0. So when you are trying to represent in BCD, compulsory it requires us 4 bits, right? 8421 code, and 4 is number 4 is 0110, right? Okay. When you are trying to perform addition, you are going to get 0 and 0 0, 0 and 0 0, 1, 0 and 1 is 1, 1 and 0 is 1. But is it a valid one in terms of BCD number? No, it is invalid because it is greater than 9 in the decimal form, right? As it is greater than 9, so when you are saying that it is invalid, you have to add 6 to this one. You have to add 6 to this one. When you are going to add 6 to this one, this is 0, this is 1, this is 1 1 is 1 0, this 1 1 is 1 0. 1 0. Now these 4 bits will be considered as one decimal digit, and this data will be considered as one decimal digit, right? This value, if you are going to add number of zeros also, its value is 1, its value is 2. So total our result is 12. This way we are going to perform BCD addition. Similarly, the same number, assume that the same number XS3 addition. XS3 addition of 8 and 4. Guys, you know, right? When you are going to get result more than the required number, so compulsory you have to take add extra 0, right? Then so in XS3, 0 will be represented as 0011, 8 will be represented as 11, that is 1011. Okay. Coming to 0 will be represented as 0011, this 4 will be represented as 7, right? 0 triple 1. So now you need to add, right? So when you are going to add, this will be 1 1 is 1 0, triple 1 is 1 1, 1 1 is 1 0, and this 1 1 is 1 0, 1 0. Carry is generated, guys. When carry is generated, what you have to do? You have to simply add plus 3, that is 0011. When you add 0011, you are going to get 0 plus 1 is 1, 1 1 is 1 0, 0 0 is 1, this is 0, this is 0, right? Yes. Now what is triple 1? Triple 1 is 1 1, triple 1 is 1 1, and this triple 1 is 1 1, this 0 0 is 1 0 triple 1, 0 triple 1, right? And for this particular data, is carry generated? No. When carry is not generated, then you have to subtract minus 3, that is 0011. So you have to take 0 0, 1 minus 0 1, this is 0, right? 0 1 0 and 0 1 0 1, right? So this is my data, right? But if you observe this value is 4, this value is 4 plus 1 5, right? It is 45, but as it is in XS3, right? If you want to have it in our format, you have to remove subtract 3, so right, so which is equivalent to again 12 is a normal number. In XS3 it should be 45, right? So if you observe 8 plus 4 12, which both are same. This way you are going to perform XS3 addition. Okay, guys, if you are getting confusion here, If you're getting confused here, how we are going to add, how we are going to subtract, try to check. Like if you take any kind of binary number, you can able to perform various kind of arithmetic operations, right? Arithmetic operation, right? You are going to have binary addition, like plus is there. Similarly, binary subtraction, minus, and you can able to perform multiplication also. Multiplication. You can able to perform binary division. So like this, there are binary arithmetic operations that we can able to perform on binary numbers, right? As usual, like what we are trying to do in decimal digits, like as our normal format, we can able to perform all in binary numbers also, right? So, for example, if you try to observe here, I will take simple example like two numbers. One binary number is assuming that A, another binary number is B. So how many possible values are you going to get? 0, 0, 0, 1, 1, 0, 1, 1, right? On these two numbers, I am going to add addition, binary addition operation, right? So 0 plus 0 is what? 0. 0 plus 1 is 1. Okay. 1 plus 0 is 1. What is 1 plus 1? 1 plus 1. If you observe here, I have added 1 plus 1 is 1, 0. 1, 0. Meaning that your result is going to be 0. Meaning that this will be sum. This will be sum. When you are trying to perform addition, your sum will be 0 when you are trying to perform 1 plus 1, 0. And for every operation, carry also will be generated. Carry also will be generated, right? So when you are trying to perform 0 plus 0, 0, carry 0, 0 plus 1, 1, carry is 0, 0, 1 plus 0, 1, carry is 0. When you are trying to perform 1 plus 1, what is 0? Normal result is 0, carry is 1. This is what you have to observe. Okay. Similarly, these two are related to sum. When you are trying to perform subtraction, you are going to get actual data subtraction, and similarly, you are going to get carry also. Right? So when you are trying to perform 0 minus 0, 0, okay, don't worry about this 0 minus 1, okay, later part will do. 1 minus 0 is what? You know, the direct thing. 1 minus 0 is 1, and 1 minus 1 is 0, right? When you are trying to perform 0 minus 0, is there any carry required? So if you observe the basic terminology of mathematics, this should be like borrow. Is there any bar required when you are trying to subtract from 0 minus 0? No. When you are trying to subtract 1 minus 0, like 1 is bigger value than 0, so you don't need to have any borrow. 1 minus 1 is both are same, so there is no need of taking any borrow. But when you are trying to perform 0 minus 1, 0 minus 1, compulsory you have to take borrow from the other side. Compulsory you have to take borrow from other side. So that's why here you will get 1, and here you have get 1. 0 minus 1 is 1, and that borrow also will be taken, right? If you observe somewhere, right, simple thing, if you are going to do 1, or else let me write here itself, 1 0 minus 1 0 minus 0 1, 1 0 minus, right? When you are trying to perform, so 0 minus 1, it is not possible, so your result you have to take borrow from here, so that here you will be got 1. So now 0 minus 1 is 1. Now if I give borrow here, this value will be 0. 0 minus 0 is 0. Okay. So if you observe in terms of decimal number, what is 1 0? 2. What is 0 1? 1. 2 minus 1 is 1. Right? What is the result 0 of 1? Which is equal. Right? Like this. Right? Similarly, when you go for multiplication, also you can do multiplication. On multiplication, if you try to perform A star B, here also there is a chance of getting carry or not. Yes, there is a chance of getting carry, because when you are trying to perform multiplication, yes, sometimes you may get. So what is 0 into 0? 0. 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1, right? Guys, will the carry will be get here? No, because If you are going to multiply two binary numbers, the possibilities are only these, right? When 1 into 1 is 1, right? It is a rule of identity property. X into x is x only. Okay, so that is what, yeah, right? Similarly, if you go for division property, a by b, right? So what is 0 by 0? See, when you are going to perform, when you have divisor as 0, then you cannot able to define the result. That is, right? Divisor as 0, result is undefined. So when the divisor is 0, result is undefined. When the divisor is 0, result is undefined. What is 1 by 1? 1 will be remove how many times from the numerator? One time. What about 0 by 1? If you take 0 by 1, 0 by 1, or else if you take the normal procedure, 1 zeros 0, 0. So you are going to get 0 as a reminder, right? So this is what you have to know, right? Right. So let me take a few examples so that you will get clear idea how the binary addition is going to happen and all those things, because you are getting sometimes confusion over how to perform three ones, or sometimes you may get four ones more, sometimes one 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 one. So at that time what you have to do? So this is what the confusion, right? So this is actually 1 plus 1 is 1 0. For that, if you add 1, you will get 1 1. For that, if you are going to add, you will get 1 0. If you are 1 1 1 0, so your result will be 1 double 0. So your result will be 1 double 0 when you are going to add 4 ones. At the time, what will happen? First 0 will be carried to next immediate number. Next 1 will be carried to next super carry. This is what you have to understand, right? So that's the reason I will take the simple examples here. Okay, fine. So for example, I will try to perform addition of 9 and 11. Addition of 9 and 11. So 9 is like 1001, 1001. 11 is like 1011. If you are trying to perform addition, 1 and 1 is 1 0, 1 and 1 is 1 0, 0 and 1 is 1, 1 and 1 is 1 0. So 1 0 1 0 100 is the answer. So which is equal to 20, right? If you observe, this is 16 plus 4 20. This way. So this is a simple thing. Simple thing. Okay, fine. So if you observe the negative part, like negation, for example, let me take 6 minus 3. 6 minus 3. Okay, if you are trying to take 6 minus 3, what is the binary value of 6? 110. 110. What is minus 3? Guys, here you may get confusion, right? This minus 3, you can repeat it in 2's complement, right? 2's complement. Okay, so then you can we can able to go with for the purpose, right? So for time being, what I will do now, I will try to represent this 6 also in 2's complement, 6 also in 2's complement, and I think this is 6 only. 4 plus 2 is 6. In minus 3 is 2's complement is what? Uh, so double 0 double 1. For this double 1 double 0. If you add plus 1, this is 2's complement. Double 1 0 1. Right? This is minus 8 and minus 5. That is minus 3. Right? Double 1 0 1. If you are going to add 0 plus 1 1, 1 plus 0 1, 1 1 is 1 0, 1 1 is 1 0. 1 1 is 1 0, right? So now here you got as carry. When you got as a carry as 1, then what you can do? You can simply uh, this carry will be discarded. Carry will be discarded. So your result is going to be plus 3. Plus 3. Guys, you can observe the formulas. See, I would like to discuss only here b minus a minus b, but I am trying to discuss which is already. I am trying to perform subtraction in many forms, right? One is b minus 1 complement, another one is b's complement also. Another one is b's complement. So when you are trying to perform b's complement, I think I have given all these formulas, right? we go with right. So observe, when you are trying to perform b minus 1's complement, you have to go with the b minus 1's complement of the subtract, and if the carry is generated, add result back to the result. That will be the final result. If doesn't carry, you have to make complement, you have to add minus. When it is performing b's complement, you have to take the b's complement of the subtractant, and you have to perform the negative operation. That is, if the carry is generated, it should be discarded. If the carry is not generated, complement, and you have to add minus, right? In our case of 2's complement, carry is generated, so you have to simply discard. You have to simply discard, right? As carry generated, simply discarded, right? So this is what the logic. So in b's complement, if carry generated, we are going to simply discard. If no carry, we are going to make complement, and we are going to add simply minus. Whereas in b's minus 1's complement, if carry generated, we are going to add to the result. We are going to add to the result. If no carry generated, we are going to simply making of complement, and then we are going to add minus, right? This is the general procedure. See, this procedure will work for everything, right? As I'm trying to work with 2's complement, as if the carry is generated, see, here I have added plus 1, right? Plus 1 I have written, meaning that I am trying to have 1's complement plus 1, so this will be the 2's complement. So the result is plus 3. But here my point is how to perform negation over sorry, subtraction over a and b, right? So if I'm going to have 6, that will be represented as 0 1 1 0, 3 as represented as 0 0 1. Now on these binary numbers I would like to subtract. That is what, right? So I have mentioned directly. What is 0 minus 1? You mentioned 0. On 0 minus 1, you have to make subtract 1, and you have to take it borrow. So 0 minus 1 is 1. So now here what will happen? Here 0 will be there. Here 0 will be there, right? As this will be given to here. Now again I need to take borrow. 1 borrowed. 1 minus 1 is, so uh, see, here it will be 0, right? So you have to take borrow. 0 minus 1. Now 1 0 minus 1 is, again you are going to get 1. Now here there will not be anything, right? 0 minus 0 0 0. So 0 0 1 1. 0 0 1 1 is 3 is the answer. Okay, fine. So take out another number. 5 minus 2. 5 is 1 0 1. 2 is 0 1 0. 1 minus 0 is 1. 0 minus 1 is 1. And 0 here 0. So this will be equivalent to plus 3. This way you are going to perform subtraction. Okay. Similarly, when you are trying to perform multiplication, for example, let me take two numbers, uh, 4, another number is 6. So this is 4, this is 6. Right? So what you are going to do? 0 multiply with 0, 0, 0 multiply with 0, 0, 0 multiply with 1, 1. Sorry, 0 multiply with 1, that is 0. When you are trying to multiply 1 with all, you are going to get 1 double 0. As usual, like normal multiplication only. 1 multiply with all, you are going to get like this: 0, 0, 0, 1, double 1, triple 0, double 1, triple 0. Right? What is this value? Right? I think 1, 2, 4, 6. 1, sorry, 1, 2, 4, 8, 16. 16, this is 8. 16 plus 8 is 24, which is equivalent to 4 into 6, 24. 24. Okay. If you want, let me take one more example. 1 double 0 1 multiply with triple 1. What is the value? This is, I think, 9. This is 7. Total you should be get 63. And 7 is 63, right? So when you are trying to multiply with 1, so this will be 1 double 0 1. This will be 1 double 0 1. This will be 1 double 0 1. 3 times of same thing. 1 1 1 1 1 1. So total is 63 only. So like this you can able to perform multiplication. Similarly, if you take division of two numbers, for example, I am trying to take two numbers, 1 double 0 1 0. What is 1 double 0 1 0? So 1, 2, 4, 8, 16. 16 plus 2, 18. So can I possible to divide with 3? Yes. 3 is like, so your result should be 6 more. Your result should be 6, right? So guys, try to observe here. Observe here. Is 1 are will it be subtracted? Is it possible? No. So what we can do now? We can take uh, 1 0 here, and then you can add one more. See, basically first we have to check with the, it's like a basic operation. 18 3, right? So when 18 3, first I will take 1. Is it possible to divide 1 with 3? No. So what I will do, I will take 0 here. Then I will get the remaining also, that is 8. So 3 6 are 18, your remainder is 0. So 0 6 will be equivalent to 6 only, right? Similarly, first try to take out this 1. Is zeros, it will be like subtracted? No, it is not possible. So next I will take one more 0. One more 0 from 10. Will it be happen to subtract 11? No, it won't be possible. So then it will take one more 0. Then you are going to get 100. 100, like 100. From 100, if you are going to get like 11 subtraction, can you do that? Yes. No. So 100 minus double 1. So 0 minus 1 is 1. 0 minus 1 is 1. Now here it should be 1. See, this will be comes here, right? As here there is no value, it is going to be taken from here, right? Now here it will be 0. It will be 0. Here it will be 1. Here it will be 1, right? So 1 minus 1 is 0. So there is 1 already here. 1 minus 1 is 0. 0. Now I will take out one more thing. 0 double 1, right? 0 double 1 is 1 1 1. You are going to get 0, right? Next you will get 0 zeros 0. So your result is 0. So you can stop, right? So this double triple 0 double 1 will be acted as number 3. So what is the result you need to get here? So here it should be like 0. So 3 6 are 18. Okay. So if you want, I will take one more example, simple one. So let me try to divide 101 with the 11010. Don't get confused. So if can I perform subtraction if I write like this? 101 is 110 is bigger than 101 or not? Yes. So 101 ones are 101. So 0 minus 1 is 1 1. So here what will happen? 0 is there. 0 minus 0 is 0. This is 0. Now I will try to do one thing down. One thing down as usual. Now is it possible to subtract? No. So then I will take 0. Then I will get once again 0. Now is it 101 ones are 101 101. So you are going to get I think 0 minus 1 is 1. 0 minus 0 is 0. 0 minus 0 is 0. So total this one is the result. Right? What is this value? You can able to convert. Okay. Next take the next number 100 100 110 right? So is it directly subtracted? Yes, 100 100. So you are going to get here uh, triple zeros. So we can neglect all this. So now you can get automatically one, right? Now next to get two more ones, you have to add two zeros. So, two more ones. 1. Now you can get as 100. 100. If you remove this, now you will get 110. 110. From this 110, can you able to subtract? Yes. Ones are 100. That is 10. 10, right? From 10, now if you would like to add one more zero, can you go with the dot? Dot. You will get one more 0. You can get 1s are 100, you are going to get the remainder as 0. So like this you can able to perform subtraction. Okay, division. I hope you understood clearly. Okay, fine. So now I think we are at here, right? So we are trying to perform excess-3 subtraction, right? So if you take out the uh, first BCD subtraction, right? So the reason why we discussed all this is like you can go with when you are trying to perform binary arithmetic operations, what will happen? That is what I would like to explain here. That's why we moved to from here to here. Okay, so the point actually here we come here is to discuss about BCD subtraction. Okay, so we have seen BCD addition. Now let us go with the BCD subtraction. So when you are trying to perform subtraction, we can do it in either in b minus 1's complement or it in b's complement. Okay, so let me take a simple example. I would like to subtract 98 and 81. Means I would like to subtract 81 from the 98. So your result is going to be 17. Right? So I would like to first do it with the b minus 1's complement, as these are decimal digits. So you may get like 9's complement or 10's complement. First we will do it with the 9's complement. When you are trying to do it with 9's complement of subtract, so first one is as usual, and the second one is what is 9's complement of 81? That is 18. Try to represent in BCD representation. So 9 is 1001, 8 is 1000, 1 is 0001, 8 is 1000. Try to perform addition over this one, and 000 you are going to get 10. You are going to get 10, right? So guys, as 1 followed by 4 zeros is a kind of invalid data. Invalid data. So when you get invalid data, you have to add plus 6. This is what we have seen. Invalid data, you have to add plus 6, right? So that carry will be forward to here. So whatever the result that we got, right? So if you add here, this should be 0110, right? What is triple one? Triple one is 1 1. What is 001? 1. What is 000? What is 10? 1011. So the result is 1011, right? In BCD addition, is 1011 is a valid one? No, it is invalid. It is invalid. So when it is invalid, you have to make add 6. Right? So 1, 1 1 is 10, 1 1 is 10, 1 1 is 10. Right? As now carry is generated, see in b minus 1's complement, when the carry is generated, what you have to do? You have to add it to the result. So add this to the result. So you are going to get 0 triple 1 triple 0 1. So I think this is 1, this is 7. Right? This way you are going to get, or you are going to perform BCD subtraction. For example, let me take the another one, 33 and 62. I am trying to perform subtraction, right? So you need to have the result as I think around minus 29. 3 plus 9 is 12. 3 plus 2, yes, minus 29. Okay, so how can you do this one? 33 should be represented as usual, as usual. 33 and 62 should be represented to 9's complement. What is 9's complement of 62? We have to subtract it from the 99, that is 37. Right? 33 as 0011, this should be as 0011, and take out this one, 0011, 7 is 0111. Try to perform BCD addition, you will get 10, 111 is 11, 11 is 10, 1010, right? 1010, is it a valid one? Is it a valid one? No, it is an invalid. When it is an invalid, what you have to do? You have to add plus 6, 0110, 0, 11 is 10, 11 is 10, this 11 is 10. So 1 will be moved to this particular location. Now what is triple one? 1 1. Triple one is 1 1, 1 0 triple one, right? Is it invalid? No. When it is not invalid and no carry generated, there is no problem. So 0 triple one followed by 4 0. So 0 triple one means 7 0. 7 0, right? So when you are trying to perform the like 9's complement subtraction, if there is no carry generated, what you have to do? You have to take out its complement. You have to take out its complement. What is complement of 70? Complement of 70 is 99 minus 99 minus 70, that is 29. For this, you have to add minus. You have to add minus. That is right. Now these two are equal. This way you can able to perform BCD subtraction. Okay. Similarly, for example, the same numbers I am trying to take 98 and 81 in tens complement. In tens complement or in nines complement, whether it whatever it may be, you have to get the same result, right? So 98 is as usual. I will write the beside one only. That is 1001 and 1000. What is tens complement of 81? Tens complement of 81 is nines complement plus 1, right? You know this is nines complement value. This is nines complement value. For that I am going to simply add plus 1. So if you add plus 1, you will get 0001, 1001. So this is tens complement. Tens complement. Let's try to add 1, 0, 1. 1 is 10, carry generated. So and this also invalid data, so you can do 0110. So 0 triple 1, 0 triple 1, triple 1 is 1 1, this is 1, this is 0, this is 1, right? Is 1011 is valid or invalid? So you can able to simply add 0110. This is 1, 1 1 is 10, 1 1 is 10, 1 1 is 10, is 10, right? Guys, if you observe, in B's complement, when carries happen, it should be discard. It should be discarded. If you observe, this is 1, this is 7. Like this, you can able to perform in tens complement. Similarly, take out the same example of 33 minus 62. So 33 I will be represented as the same one, 0011, 0011. 62 in tens complement. Nines complement is 37, this one. So in tens complement is, I think, so there is no change in the 3. There will be change in this one. So this will be added plus 1, that is 1000. 1000, right? If you are going to add this one is 1101, right? Why is 1011 is existed? No. So 0110 will be happen. 011, this is 1, this is 10, this is again 10, this is again 10. Carry will be generated here. Right? Now, triple 1 is 1, sorry, it should be 1 1, 1 1. Triple 1 is 1 1 1 0. 0111 is a valid one. So, you are going to get, observe, you are going to get here as 7 and 1. 7 and 1, right? So, meaning that when there is no carry generated, what you have to do? You have to make its complement. You have to make its complement. What is the complement of 71? Complement of 71 is 100 minus 71 is 29, right? That is 29, and from that you have to append minus. So the result is going to be get like this, right? So if you want, you can find out the complement of nines. Nines complement is what? Nines complement is 28. For this, if you are going to add plus 1, you are going to get tens complement. We are trying to work with tens complement, so you got the result, that is minus 29. So this is the way you can able to do, right? The simple thing is you have to perform either nines or tens complement of subtrahend, and you have to follow the basic procedure, either b minus 1's complement or b's complement procedure. That's it. Similarly, take out the another kind of coding mechanism, that is Excess-3 subtraction, right? In Excess-3 subtraction, I will take the same examples only. So I think I have taken here 98 and 81. 81 and trying to subtract, you are going to get plus 70, right? So guys, in Excess-3 what will happen? In Excess-3 we are going to represent 9 as 12. So right, so 98 as 12. So when you are going to represent as 12, it should be 1100. 8 will be represented as 11, meaning that we are going to extract plus 3, right? 1011, right? And what about the negative number? Negative number again you have to represent in either nines complement or in tens complement. I will try to find out the nines complement of 81. Nines complement of 81 is 18. That 18 should be represented in XS3 representation. That is I think one XS3 is 4, 8 XS3 is again 11, 1 0 double, right? Yes. Now try to perform XS3 addition, right? So 1 1 is 1 0, triple 1 is 1 1. This is 1. This is 1 0, 1 0. Guys, try to observe in XS3 addition. In XS3 addition, when there is a carry generated, what you have to do? You have to add plus 3. You have to add plus 3. What is plus 3? 0 0 double 1. Try to do 1 1 1 is 1 0, 1 1 is 1 0, this one 1 double 0 1. Okay, now this one is 1 0, 1 1 is 1 0, 1 1 is 1 0, right? As we are trying to perform at a 9's complement, whatever the carry that we are trying to generate, that should be added to the result. That should be added to the result. So here we are going to get 1 0 1 0. This will be as usual. Right? So as here carry generated. When carry generated, what you have to do? You have to add plus 3, double 0 double 1. Right? 1 1 is 1 0, 1 1 is 1 0, this is 1, this is 0. This carry will be as well comes here. So the result will be 0 1 double 0. So what is this value? This value is 4. This value is 8 plus 2 10. Right? 1 7 in XS3 is 4 and 10 or not? 1 plus 3 is 4, 7 plus 3 is 10. So this is the way you can able to perform subtraction. Okay, fine. So which is equivalent to 17 again. Now try to take out the other number 33 and 62. You need to get minus 29. So try to take out 33 in XS3 notation, that is 0 double 1 0 6, and another 6 is 0 double 1 0. What is 9's complement of 62? 37. 37, if you are going to represent in XS3 notation, 3 acted as 6, 7 acted as 10. 1 0 1 0. Try to perform 0. This will be 1 1 1 0, 1 1 is 1 0, 1 1 is 1 0. Carry will be different, right? When carry will be generated, you have to add plus 3, double 0 double 1. You will get double 0 double 1. This is 1. This is 1 1 is 1 0, triple 1 is 1 1. Right? Here no carry generated. No carry. When no carry generated, you have to subtract minus 3. Minus 3. That is 1 1 is 0. 0 minus 1 is 1. Here 1 minus 1 is 0. Here it will be as usual 1 0 1 0, right? If you observe, this is 10, this is 3, and this is 3, right? Yes. So meaning that which is equivalent to 70, which is equivalent to 70, right? 70, and this is, there is no carry generation, right? In b minus 1's complement, when there is no carry generated, what you have to do? You have to find out the complement of 70. Complement of 70 is what? 29. And for this 29, you have to add minus number. That is minus 20. Like this you can able to perform. The same numbers I would like to do it in tens complement. 98 minus, that is 70. 98 is as usual, double 1 double 0, 1 0 double 1. But for 81 complement is 18. But we are trying to represent in 9's complement, 10's complement, that is 19. So 1 is as usual, like 0 1 double 0 only. 19. 19 means what? Like 8 is 11, 9 is 12. Double 1 double 0. Right? This is 12 mark. I hope you understood. No need to write. Try to do what is addition. 1 1 1. This is 1 0. Carry generated. You have to perform addition of 3. This is 1 1 1 0. Triple 1 is 1. 1 1 is 1 0 1. 1 0 1 0. Now this is 1 0 1 0. 1 1 is 1 0. 1 0, right? As carry generated, you have to add double 0 double 1, right? This is 1 0, this is 1 0 1 0, right? What about this carry? This carry should be discarded. In this complement we are going to discard the carry. So this is what, 4, this is 10, right? Which is again equivalent to XS3 value of 17, right? Take out the another one, 33 minus 62. We are going to get minus 29. So 6, so you can take these numbers 0 1 1 0 0 1 1 0. I think this should be 38. So actually this is 37. In tens complement that is 38. So 38 means this is also 6. So 8 means 11. 11 means 1011. So this will be 1. This will be 10. This will be again 10. This will be 10. Carry generated. You have to add plus 3. 1 1 is 10. 1 1 is 10. This is 1 0 0 1 0 0. Now this is 1. 1 1 is 10. 1 1 is 1. This is 1 1 1 0 1. Right? When there is no carry generated, you have to subtract 3 0 0 1 1. So 1 minus 1 is 0. 0 minus 1 is 1. See guys, you have know the formula. This one is 0 minus 0 is 0. This is 1 0 1 0. Right? Which is I think this is 10. This will be 4. This will be 4. So you are going to be represented as 7 and 1. 7 and 1. So in B's complement, what you have to do? You have to be tens complement. Tens complement. Then for that you are going to add minus. So your result will be minus 20. So here also we are going to do the same procedure, but here the thing is you are going to add plus 3 for each and every individual decimal digit. Okay, which is same as BCD subtraction. See, subtraction is same for all kind of systems. Okay, I hope you understood clearly. Thank you.